Today we're going to be taking an in-depth look inside of the electronically continuously variable transmission out of the Toyota Prius hybrid. Now in the first part of this series, linked above, we explored how the hybrid system works from the battery to the inverter and how it all controls this transmission. Now in this video, being the second part, we're going to be taking a look inside this transmission to see how motor generator 1 and motor generator 2 work together in order to give the proper gear ratios for this continuously variable transmission. Now this transmission is very different from your conventional CVT that has a belt that drives it and changes cog ratios. In this case we have two electric motors, which you can see the orange wires going to them over here that run off of three-phase power. Now in a typical CVT or an automatic transmission, you normally would have a torque converter mounted inside of this bell housing area that connects to the input shaft. Now the Toyota Prius, they've actually opted to use a manual transmission style flywheel. You can see this here would be the flywheel. It's got some weight to it, and that's going to be mounted to the crankshaft of your internal combustion engine. Then you've got a clutch or a torque damper. It's got these springs inside here that's going to mount inside of here, and then you've got what would be the equivalent of a pressure plate, which is going to squish down on that clutch. Now this clutch is always applied. There's no engagement and disengagement of this clutch, but essentially this is what forms your flywheel assembly. This part of the transmission faces the front of the vehicle. Now taking a look here, we do have our big electrical connector here that's going to power motor generator 1 or MG1. That's situated near the bell housing part of the vehicle, which acts like an alternator and a generator against that engine. Taking another look around here, you can see we've got these two coolant hoses here, and that's part of the cooling circuit that's inside of this transmission. Now, coming around to the back of the engine here, you can see we've got a connection for motor generator number 2, which is the larger of the two motors, and that's housed in this side of your CVT. Now back here we do have your parking pawl mechanism, and then in this part over here we have our final drive or differential, and that's what's going to go to the axle. Now this engine's got a lot of 10mm bolts holding everything together, so I'm just going to start taking things apart. Yeah, I'm going to use my wife's toothbrush to clean this out. And then pop off this actuator. It seems like we've got a bunch of electromagnets that are going around here, which is what's going to cause this thing to turn when you activate it with power. And then that's going to turn this ring gear on the outside here and actuate this inside of here in order to turn on your parking brake mechanism. Looks like we got some coolant passages in here. And a big giant void inside of here. Uh-oh. Right, luckily I got my wife's pants here handy. I'm going to soak that up. Inside of here we actually have a little oil pump because there is some transmission fluid in here to keep things well lubricated. You can see that's driven off of this shaft here, and this shaft connects to the planet carrier on the inside that's always rotating. Now this oil pump works like any other oil pump where you've got fluid that's drawn into here, and then as this is turning here you can see these veins are going to squeeze it inside of here, and that's going to create fluid flow. It's then going to exit out through this port over here down to the regulator and then back into the transmission to be circulated. Take off this back cover now. Now we're in trouble. The whole entire transmission is draining out on my driveway. I gotta go look in my wife's wardrobe. I'll be back. I also have her pants here, and I also stole the skirt. Hopefully that'll clean up everything. Meanwhile, I'm just gonna work on prying this thing loose here. Alright, so interestingly enough, the transmission oil is actually floating around inside of the entire housing. Anyway, on this back casing here, you can see we've got this wire that leads up to the sensor, and it's got these magnets inside, and that's to sense the speed of MG2, so the computer knows how fast it's going as part of a closed loop control circuit. Now over here you can see we've got our three-phase power that's going to come into MG2 over here, which has 3 different coils. We've also got another sensor wire over here, and of course the end of the shaft has this bearing. Yeah, this is a temperature sensor. It sits at the bottom of MG1. I'll just unbolt this three-phase power here. So we're going to leave this side and go to the other side and open that up. So removing this cap over here reveals the contacts for MG1. I can slide this plug out. Interestingly, this wire here is actually made up of 3 smaller wires here with this copper sheathing on the outside. Now some of these bell housing to transmission casing bolts, which are 12mm, are real bears to get to. I can't get to it with an impact or even a ratchet. I gotta use my ratcheting wrench, and they have pre-coat on them, which makes it a lot tougher. Alright, so I've removed all those bell housing bolts. Finally been able to bust this case open here so you can see what's inside. I can peel this thing off here. Now taking a look inside of this Prius's transmission, over here you can see MG1, which is closest to the engine. There's an internal gear here where MG1 drives, as well as a bearing face. That is going to interface over here where we have the shaft, which is the input shaft that connects your internal combustion engine. And then here we've got this smaller gear, which is actually the sun gear of your planetary gear set that connects to MG1. Now over on this side of the transmission, inside of here we've got MG2, and this is your power split device or your planetary gear set. Now coming off of that we have this chain here, which is what's going to drive the rest of the transmission. This is going to take all the power from the motors combined as well as the engine and transfer it over to this countershaft over here, and then another countershaft over here. This one you can see has got the teeth that's going to lock your parking pawl in there to keep it from moving when you've got it in park, and that's going to go over to your final drive over here, which is a differential where your axles are going to plug in to turn the wheel. You can see this here is your little parking pawl with the tooth on it that's going to interlock with this shaft over here to lock it. So as I take this power split device apart here, you can see the chain is actually driven by this piece over here. Now this piece has these teeth on it, which is going to interlock with the ring gear on our planetary gear set. So if I take out the planetary gear set, you can see we've got a sun gear. Now this sun gear is going to plug into MG1 on that side of the case over there, and that's what's going to turn this way. We've got our planet carrier itself here, which is connected to the input shaft, which connects to your internal combustion engine. And then the ring gear over here is driven by MG2, located down inside of this casing here. So basically the ring gear is always connected to your output through these teeth over here. The input shaft is driven by the internal combustion engine, and then the sun gear is driven by MG1. So just a single planetary gear set is going to take all three components and put it together to come up with a proper gear ratio and speed to turn that chain and then the wheel. This gear is actually splined to the inside of the ring gear over here, and that's MG2 down inside of there. Now furthermore, on the back of this planet carrier, whenever it rotates, it's going to drive this extra shaft here, which is going to go to the oil pump at the back of the transmission. So I'm going to remove all these 10mm bolts that hold MG1 to its case. So I pried this up. I think it's going to take some considerable force. Oh, never mind. To take it out of the case, the magnetic force here that holds it inside. And it looks like we've got an extra wire here. It's going to control some sort of a rotation sensor. I'll just carefully disconnect that connector. Alright, so here you can see the internals of MG1. This is the one that sits next to the input shaft and is ultimately going to be the one doing the starting and some of the generating of the power. You can see here we've got our three-phase cables that goes to the stator, and the stator's got these windings. Now these windings are going to be in three different sets as you go around here because it corresponds to the three different phases, U, V, and W. Over on this side here you can see we've got the rotor for MG1. Now this is where your permanent magnets are situated inside of here, and that's connected to this casing. Here you can see I've got the sun gear from the planetary gear set. This is how it's going to connect over to MG1. Okay, so I've got this thing on two bricks here, and I got a socket that fits in there perfectly. I'm going to attempt to press out the rotor off of this casing here using my 2-pound press. Alright, so on top of this rotor here you can see we've got our magnetic sensor. It's got a bunch of coils on the inside here, and that's going to pick up a signal coming from the rotor over here. You can see there's an eccentric washer that sits on top of here, and as that rotates, well, it's going to trigger these coils inside of here and send the signal out to the computer so you know how fast MG1 is going. So here is the rotor for MG1. You can see it's quite heavy. Now this basically has a bunch of magnets that go inside of here. And you can see that these are a bunch of steel plates that are just laminated together. So I've chewed through the lamination over here by just punching it in. And now, the center of the rotor, seems like it can come off here. Here's what the rotor looks like, and this is where the sun gear is going to plug into. And here you can see the bunch of steel plates that they put together with the magnets inside of here. I wonder if I could just peel these plates off. Kind of strong. Oh, okay, there's the main plate. If you take all the plates apart, like I've done here, we're basically left with a bunch of these magnets. There's a total of 8 of them that run in this rotor, and they're pretty strong magnets, so make sure you don't get them next to your brother's car or something. Alright, so now if I dump this case over, now when power is sent through these 3 phases over here, it's going to energize that coil, and that coil is then going to become an electromagnet, and then it's going to go get attached to one of these magnets over here, and that's what causes it to rotate. Now the reason why you have 3-phase power is because if you only had 1 phase, well, your rotor is going to rotate 180 degrees. But if you have 3 phases, it's going to rotate 120 degrees, then 120, and then another 120, therefore giving you more torque and also generating more power when in generating mode. And you can see similar to the rotor, we've also got a core here that's made up of a bunch of small steel plates laminated together. Now inside this casing, you can see we've got our 2 coolant hookups here, and that's going to go to a giant cooling compartment in behind where the stator sits, and that's going to help cool down MG1. So in order to get this case free, I need to remove these countershafts in the final drive. There's this big nut here which I don't have a socket for, so I'm going to use my special socket removal tool to bust a nut. So now that I've made some incisions there with my nut removal tool, I'll go ahead with my mechanical press here, and there you go, I've busted a nut. You can see it's got the other end bearing over here that sits in the casing. And then I can remove the chain. Now the chain itself kind of looks like a bicycle chain, but it's a lot broader. I'm sure this has to be built to handle all the torque from the electric motors. plus the internal combustion engine at full speed. And I do have another video on how differentials work, so you might want to check that out linked above. Now more importantly, at the bottom of the transmission case here you could see the filter, and this vehicle had almost 500,000 kilometers. The filter doesn't look too bad or clogged up. In order to change the filter you do have to open the transmission, unfortunately. Now the drain plug itself is the one that has the magnet on it. This doesn't have a dedicated transmission panel. So here we are on the back of the casing where there's MG2. I'm going to try to hit it out from the back here. Here you could see MG2 removed from the casing. Now it's got this rotor that's really stuck in there because it's magnetic. So you really need a huge amount of force in order to press out the rotor. No. Yeah, I got it pushed down there. Now taking a look at MG2 here, you can see that the rotor is a lot bigger than the one I took apart from MG1 here. Now this is the one that ultimately drives the wheel. Now here we've got the spline that's going to connect to this piece here, which connects to the ring gear on our planetary gear set. And of course we've got our magnets on the inside and an end bearing for the back of the transmission. Alright, so I've undone the lamination. I can take out this top plate here. Here are the plates here that form MG2. You can see how much larger these ones are. You can try to separate that. Looks like one set here. You can see the magnets here have a V shape, whereas on this one the magnets just have a slotted shape. So they actually use different magnets in MG2. Okay. Here's the other set, and you can see there's more magnets in here. Alright, and there I can take out the center portion. So unlike MG1, which only had one set of magnets, this is like 3 sets of magnets put together. Here you can see you've got the stator for MG2. It's a lot thicker and larger than the stator for MG1, and that's because arguably it does most of the heavy lifting, as it's directly connected to the front wheel. Now you can see inside of here, each one of these slats represents an individual coil winding, and we've got our 3-phase U, V, and W power that's going to come in here to allow that rotor to have a very small resolution and thus a very high torque. Now generally speaking, this one does more of the generation and starting of the engine, while this one here does more of the propulsion of the vehicle, except when they're both in regenerative mode, generating energy. So here you can see I've got the entire transmission out on top of these V-blocks here for demonstration. I've got the rotor for MG1 here, which connects to the sun gear. I've got the rotor for MG2 here, which connects to the ring gear, and that connects to the chain that goes to the wheels. And then we've got the flywheel from the engine here, which feeds the planet carrier. Now here I've graphed the rotational speed of all the components in the power split device. You can see we've got MG1 over on this side with a maximum RPM of 6,500 and 6,500 in the opposite direction. MG2, which rotates proportional to the vehicle speed, has a maximum of 6,000 RPM, and then you've got your internal combustion engine, has a range of about 1,000 RPM to 4,500. Of course, the internal combustion engine can also be completely stopped at an RPM of 0. Now this graph is kind of the brains of the ECU. In order to come up with an appropriate road speed, you need to draw a line between MG1, the internal combustion, and MG2 through the planetary gear set in order to come up with an appropriate rotational combination for it to result. The 6 main modes that this power split device can provide useful work. The first of which is if your engine is off and you want to turn at a very slow speed, well, you're going to apply power to MG2, and that's going to directly drive the wheels on electric power alone. Now you're also going to notice that MG1 over here is spinning at a much faster rate than MG2, but through the law of conservation of energy, we're not going to use that as a generator because it's just pointless to use electrical energy to convert it to mechanical energy and then back again. Now in our first scenario, starting off from a stop, we're going to start here on this green line where our internal combustion engine has 0 RPM and is held stationary. You can see here our vehicle speed is going to be about 20 miles per hour, and that translates to an MG2 speed of about 1700 RPM. If you follow that green line down, it lends you to about 3000 RPM in the opposite direction for MG1. Now on electrical power alone, if your internal combustion engine has a 0 speed and you absolutely redline MG1 to 6500 RPM, follow that line up and you'll see that the maximum speed the vehicle can reach is about 42 miles per hour on electric power alone. Now the second mode is if we want to start the engine. So we're moving along here at a very slow speed, and then we apply an opposite torque to MG1. Well, that's going to cause the internal combustion engine to start up because MG1 acts like a starter, and this is going to turn this to move it forward. Now the engine is started. Now with your internal combustion engine rotating, you can still have MG2 driving the wheels, but you can see MG1 is also rotating at a much faster speed. So at that point you can use MG1 as a generator to charge your battery pack. As far as actually varying the speed, if you put more power to MG2, well, it's going to rotate the wheels faster, but if you want additional power from the internal combustion engine and you rev it up, well, the differences of speed between the two are what make the continuously variable aspect between them. Now in our second mode, we're going to follow this blue line over here. Let's say we're still at 20 miles per hour and the engine wants to start up. Well, instead of having a negative direction to MG1, we now have have to have a positive direction, so we have to counter torque that in order to start the engine. The engine will now run, say, at 1700 RPM, and if we extrapolate that over, we get about 3000 RPM rotational speed for MG1 at 20 miles per hour. Now at that speed, you're happily able to coast along on both internal combustion and motor generator 2 powering the vehicle, while MG1 is generating electricity to be fed back to the battery. You can see here, as we control the amount of counter torque applied to MG1 or the RPMs of the internal combustion engine, we can change the slope of this graph here, and that's going to slowly bring up your vehicle speed to a cruising speed. Now let's say we've brought the vehicle up to about cruising speed here at 52 miles per hour. Well, that correlates to about 3100 RPM for MG2. If we follow that line down, that's about minus 2000 RPM for MG1. It's in the opposite direction, and that's going to intersect the internal combustion engine at about 1700 RPM. We want to keep the RPMs nice and low to keep this thing from burning too much gas and to make it nice and efficient. Now in mode 3, during acceleration, you're going to have your internal combustion engine that's rotating and MG2 that is rotating. This is contributing directly to the wheel speed, whereas the internal combustion engine is both helping this guy out, but it's also rotating MG1. Now that MG1 can be used as a generator to generate power and charge the battery pack, but it's the variation between the internal combustion speed and the difference of the ring gear, or MG2, that allows the continuously variable aspect of this transmission to work. The more power and RPM you put to your internal combustion engine and MG2, the faster it will go. Now, a lot of people wonder what happens when you're accelerating really hard up a mountain pass on the highway for a really long time and your battery runs out to power MG2. Well, since there's no more battery power that can contribute torque to this, you're only going to be relying on your internal combustion engine, and your car is going to slow down pretty hard because this internal combustion engine only has about 76 horsepower. It runs on the Atkinson cycle, which is better for efficiency, so you're going to have a very slow car. Now, in addition, you can also see anytime the internal combustion engine is on or it's revving really high, such as on the highway, and it has to contribute power, well, you're burning gas, and that's why hybrids are more efficient in the city, where you're using more electrical energy and regenerative braking than actually using the gas engine. So now let's say we're in mode 3, you're cruising along and you see another Prius and you want to pass him. Now you're going to mash the accelerator pedal all the way down. That's going to cause the computer to rev up the internal combustion engine to add a lot of torque to MG2 to give you that acceleration, which is probably not even as fast as a shopping cart, and that's going to be defined by this brown line over here. Now the maximum MG1 can rotate is 6500 RPM, so if we draw that line to your vehicle speed, that means we've got an internal combustion rotation at about 4000 RPM. Now this curve is going to slowly start to flatten out as your vehicle speed increases. Now in the fourth mode, during regenerative braking, your wheels are actually going to be doing the turning through the chain mechanism, and that's going to cause MG2 to become a generator, and MG1 can also be a generator, and that's going to pick up back current and bring it back to charge your battery if your internal combustion engine is off. If your internal combustion engine is still running, let's say if you got it in B mode and you're going down a hill, that means you want to use engine braking instead of regenerative braking in order to slow the car, similar to putting it in low gear in a conventional transmission. Well, that's going to allow the power to come through this ring gear over here and use the compression of the engine in order to slow you down. Therefore, you're not really going to be generating as much energy, but you are slowing down without burning out your brakes. Now in our fifth mode, let's say the engine is off and you want to reverse. Well, I can apply some power in the opposite direction to MG1, and that's going to cause MG2 to rotate backwards and reverse the car. However, if the internal combustion engine is on, I must now apply a lot more RPMs in order to counteract the gear ratio so that I can get the vehicle to turn backwards. Alternatively, we can just apply power to MG2 and have everything work in reverse if the engine is off. We have to be careful that we don't reverse the motion of the engine, because engines are only meant to spin one way. Now in mode 5, we're going in reverse, following this pink line here. Now I wouldn't want to be next to a Prius going 10 miles an hour in reverse, but if that's your vehicle speed and your internal combustion engine is shut off, MG1 should be rotating at only 1500 RPM. However, you can see that if the internal combustion engine is on, MG1 has to rotate at a much faster speed. You can see 5600 RPM over here in order to counter the torque coming from the internal combustion combustion engine in order to push MG2 backwards at 10 miles an hour. Now, a lot of people wonder what happens when your battery can't take any more charge and needs to be replaced. Well, your vehicle's still going to work, but it's going to be quite jerky and very slow. You're still going to need a little bit of juice in there so that you can turn MG1 in order to start the engine, because the engine itself does not have a dedicated starter or an alternator, so that's going to have to start the engine. And now, because the engine only works between 1000 and 4500 RPM, there's no clutch mechanism like in a manual transmission or a torque converter mechanism like in an automatic transmission. So you're just suddenly going to start turning at 1000 RPM, and you're going to have a really jerk reaction as the vehicle begins to turn, because MG2 does not have anything powering it to slowly start turning. It's just going to instantly engage. Now, in addition, since you don't have anything powering these motors, you're just going to be relying on the 76 horsepower 1.5 liter engine alone, which is going to be pretty slow overall, but it'll get you home eventually. Now, these generators can still work themselves, but if your battery does not hold any charge, there's a 12-volt inverter that's supposed to run all the computer systems in your car, and if you don't have any battery charge, well, you're not going to have a 12-volt source, and then eventually your car is going to die. And that's pretty much how the torque split device works in the Toyota Prius. It's a pretty simple mechanical system with just one planetary gear set. A lot of the new Toyota Priuses have gone to a double planetary gear set to achieve a further gear reduction for more efficiency. And that's pretty much an in-depth look inside of the Toyota Prius's hybrid transmission. You can see, mechanically speaking, it is very simple, just having a planetary gear set, and it's amazing how you don't really have any gear shifting devices the way you would in a manual, conventional CVT or an automatic transmission. Now, if you missed part 1 on how the hybrid system works to control this all, make sure you check that out. So the next time you jump into your hybrid vehicle, or you're stuck behind that slow Prius on the highway, think of all these components that have to go in just to make it work. Now, make sure you follow me on Instagram for more behind the scenes footage, and subscribe for more videos just like this one. That's